our our instrument. Now we'll see the other than precision and bias error, there can be illegitimate errors. So these errors occur due to the mistakes made, like blunders or mistake made during the experiment, like you incorrectly write the reading. It is 18, but it is 18, but you see that it is 10. Okay, so you incorrectly write the reading. And next is there can be various devices in your experiment and you forget to switch on particular supply. Okay, so that is illegitimate errors. So it can be also the computational errors made by the person involved in the research. Okay, so all this goes to the illegitimate errors. Now, sometimes what happens, we are not very much sure whether the error is bias error. Sometimes it is a precision error. Okay. So errors because of instrument backlash, friction. Okay. Friction and hysteresis. So hysteresis is the type of the error which occur if you go in a different way. Okay. Suppose you go on increasing the value. Like suppose this is our indicated on instrument, and this is the actual value. Okay, so when I go on increasing the value, it will have certain value. If I goes on reducing this value, so I get different curve. Okay, so this is called as what? Hysteresis. So if you say when we go for rising the value, you read different, and when you come down from the high value to low value, it gives a different reading. That is called as what? Hysteresis. So this type of error occurs, and we can say it is either neither bias error nor precision error. Okay, so it is a combination of that. Okay, so as I mentioned earlier, we need to estimate the error and try to minimize it is required if it is required. We already seen the uncertainty analysis, and in uncertainty analysis, we try to minimize the error uncertainty. So it is about precision type of the errors we want to eliminate. Okay. So errors from calibration drift or variation in environmental conditions, error resulting from variation of procedure. Please understand, we started the definition of research that we need to be systematic and we need to follow the procedure. Every time we need to follow the same procedure. If you deviate the procedure, what will happen? There will be error. Okay. So we need to strictly follow the procedure. So as I mentioned earlier, our error in the measurement should be not more than 5%. To create confidence in our readers that our readings are whatever the indication given by the readings is correct, and whatever the conclusion we draw, it is acceptable. Okay. Suppose your phenomenon is showing that there is a rise of 8% performance, but your measurement itself is having 10% error. So no one will believe your results. Okay. No one will believe your results. So now we'll move further. Now, as I mentioned, so it is just like a statistic. Now, when we go for what is called as random error or precision error, it is just like a statistic. We need to take the help of the statistics. Then we need to plot the probability density function. Okay. So we characterize the probability that error of a given size will occur. So we see the distribution of error. So we take many readings. So when we take very large number of reading, we can say it is a population. But we cannot have the population, because what happens, we have limited time. So what we do, we take the sample readings. So sample is very, very small as compared to the population. So I can give the example of the sample is, we take, suppose there is a bag of marbles and we take some 5 6 marble from that bag. So that samples, the 3 4 marbles taken is what? Sample. And the bag represent the population. Okay. So it comes again statistics. Statistics is involved. So we can see here 2 types of domes, probability density distribution domes, normal distribution curve. We can see here the base is bigger, and in one case the base is smaller. Okay. So the base is bigger for the case where sigma is smaller. Okay. Where sigma is smaller. Base is big where sigma is bigger. Okay. More the sigma, more is the bigger is the base, smaller the sigma, smaller is the base. Okay. So when we make it smaller base, what happens? Its height increases. Okay. So height increases means what? Probability increases, because the area is same. What we are doing, we are shifting the area. Okay. We are shifting what? Area. Okay. So their height will increase. In short, what is happening? Probability is increasing. Okay. So this is now I will show you probability density function. Okay. So it is f of x is 1 by sigma square root of 2 pi exponential of minus x minus mu square divided by 2 sigma square. This is the probability density function. Okay. So when we plot this, we get the curve, we call it as what? Z table. So already given the Z tables. So the Z table I have given, measures from the, we can say, left hand side. Okay. It measures from the left hand side. So the Z table given by me measures from the left hand side. Okay. So here, suppose the Z maybe suppose 1.1. So in my case, it will be this much. That is a 0.5 area. The total area will be what now? 0.5 area plus this area. Okay. So that will be the value related to the Z. So we know the Z value is what? X minus mu divided by sigma. X is the value, minus mu is what? Mean, divided by the sigma. Okay. In this way, how the standard normal distribution curve is related to our probability. So what we want is we want to see the probability. So whether it is error analysis, whether it is what is called as hypothesis testing, all it is related to the statistics. So again, same thing here. How much is the spread? How much confidence we want? Suppose I want 68.3% confidence, then it will be plus minus 1 sigma. Okay, spread will be plus minus 1 sigma. Suppose I want a 5% confidence level, so it will be 1.96 plus minus 1.96, like this. Okay. If you want 99.7% confidence, then it will be 3 plus minus 3 sigma. Okay. So I have already shown you the deviation. Di is the deviation and sigma is standard deviation. Okay. So we have already seen the value of Z. These tables I already provided. Okay. Now, such as short problem you can solve. Suppose Z is minus 1.45 to Z is equals to 1.45. What is the area? What is the probability? You can find out, okay, from the table. And you have to also mention what is the significance of this area. That is a probability. When we find the area, and that will come in a fraction. If you multiply by 100, that is the probability that value will lie in that area. Okay. So you solve the problem. I will say the problems for assignment. You solve that. Okay. You solve them. You'll get confidence. Okay. So this is about the error analysis. So we'll stop here. And
Sir?
yes.
Sir, similar type of problems will come in the examination or in, can you give us the
Yeah,
some examples
similar.
for the
Whatever,
practice?
whatever,
Yeah.
whatever I cover, similar problem will come because many students are not from the engineering or mathematics background. Okay,
Yes, yes.
so you learn the method because I will send you the table. From table, you have to understand. So you have to basically
Yes.
learn using the tables, the Z tables.
Yeah.
Okay, and
Sir, in the assignments, you give us the problem for the practice, so it will be easy for us.
yeah, assignment I will give the problems and similar